Hello, how you doing? Are you familiar with how swarm intelligence has inspired agentic design? Well, if not, then watch along with me for the next few minutes and I'll quickly get you up to speed. Okay, let's get started. First, I just want to make sure everyone watching this video is aligned with what I mean by swarm intelligence. So what is swarm intelligence? Well, you can easily find it in the natural world. For example, have you ever noticed how ants always seem to know exactly where to go? Or how a flock of birds can turn instantly, all at once, like they share the same mind? Well, this isn't magic, and it isn't chaos. This behavior comes from something called swarm intelligence. Swarm intelligence is where many simple individuals create sophisticated collective behavior together. Swarm intelligence is the idea that a group can be smarter than any one member. Each individual only follows simple rules, reacts locally, and uses the information right around them. No one is in charge, yet the group solves complex problems, such as finding food, avoiding predators, or adapting to change. So in simple terms, swarm intelligence means simple agents making local decisions, leading to intelligent global behavior. So how does swarm intelligence in nature influence agentic design? Well, if we consider a basic single agent linear workflow, we see that it does the first task, then the second task, and finishes with a third task. It's clear, orderly, and predictable. This works, but it's limited because it doesn't adapt easily when conditions change. This simple example would not be something I would say has been inspired by swarm intelligence. Now, consider a use case that's a little more complicated that requires a multi-agent design. Imagine a surf forecast system producing an hourly surf report using decentralized agents, local rules, and emergent consensus. The goal of this multi-agent system is to produce a trustworthy, spot-specific surf report that would include wave heights, wave period, wind, tide, crowd, and confidence scores. I would do this by extracting raw data from buoys, wind vanes, surf cams, and local knowledge without a single supervisor agent. This multi-agent workflow will allow surf forecast agents to interact, coordinate, and update in real time. There's no fixed path. The agents cooperate, share signals, and adjust as situations evolve. Okay, so next let's go deeper into what principles this multi-agent workflow has borrowed from swarm intelligence, and more specifically, an ant colony. The first principle is local rules lead to global solutions. Swarm intelligence operates on the principle that local interactions among agents can lead to global solutions without a central authority. So first, how is this manifested in an ant colony? Well, ants don't have a leader assigning roles or giving orders. Instead, each ant follows simple local rules such as follow the strongest pheromone trail, leave pheromone when you find food, avoid obstacles, and adjust your path as needed. Just so everyone watching this video is dialed in, ant pheromones are chemical signals that ants use to communicate with each other for a variety of purposes such as making trails, signaling danger, and coordinating social behaviors. So if every ant follows these local rules and behaves this way, the colony collectively finds efficient paths and adapts to changes. So how do agents implement the principle of local rules lead to global solutions? Well, in our surf forecast agentic workflow, each agent follows predefined rules, interacting with its immediate data source to contribute to the overall system's goals. For example, the buoy agent pulls wave height and period data from nearby buoys. The wind agent gets wind speed and direction from a wind vane located at the surf spot. The crowd agent gets screenshots of surf cameras directed at the surf lineup and approximates the crowd size. These interactions, though local, are designed to produce a coherent global outcome similar to natural swarm behaviors. So what is the next principle of ant colonies that multi-agent workflows share? Well, ants use signal trails to communicate. As mentioned earlier, ants use pheromone trails as a form of communication, marking paths to resources which other ants follow and reinforce. This decentralized communication method allows the colony to efficiently locate and exploit resources. So what is the equivalent of signal trails in our SURF forecast agentic workflow? Well, in this system, agents share their data or signals to communicate indirectly, similar to pheromone trails in ants. Signals that agree across agents get weight boosted. Stale and contradictory inputs lose weight over time. This aggregated data, which generates a final scorecard, is the stable consensus of all the agents and not just the opinion of a single agent. Another principle of the ant colony is no single point of failure. Ant colonies are resilient because they do not rely on a single ant. If one ant fails, others can continue the task. This decentralized structure ensures the colony's survival and efficiency even if individual ants are lost. So what is the equivalent of no single point of failure in agentic workflows? Well, in agentic systems, the absence of a central authority means that the failure of one agent instance does not compromise the entire system. Note, in a proper agentic deployment, you would have agents deployed across numerous containers or VMs, ensuring horizontal system redundancy. This design principle enhances the agentic system's robustness and fault tolerance, allowing it to continue to operate despite individual agent instance failures. The fourth principle of ant colonies seen in multi-agent design is emergence instead of programming. This can be seen in ant colonies that are solving problems no individual ant understands. An example of this is when the colony solves the problem of shortest path optimization. This colony solves this problem, yet no ant holds the map. This is described as emergent intelligence. In our SURF forecast system, no single agent can generate the final SURF forecast. Each agent only executes on a specific role, and the collective of all the agents produces a realistic, evolving SURF forecast. Okay, so let me know what you think of swarm intelligence and its influence in multi-agent workflows. Do you think you might be building agentic systems using these concepts in the future? Feel free to share your thoughts in the comments below. I want to hear what you think about this topic. Okay, thanks for watching. This video, along with all the other videos in this playlist, are listed in the YouTube description. I invite you to watch other videos on my channel. If you like the way I'm sharing this content, please consider subscribing. When you subscribe, this really helps my channel grow. One last thing, we all love technology, and we're all excited about all the innovation with the cloud and machine learning and AI. But don't forget to carve out some time to live in the real world. Go outside, go swimming, go hiking, go climbing, go surfing. Get out and move your body. And if you do, let me know in the comments. I want to hear about this as well. And with that, have a great day. Thanks.